So now that we have an understanding of our trig ratios, why do we need to know that, right? So let's take a look at an example. A plane takes off and climbs at a 12-degree angle. Is that angle sufficient enough to fly over an 11,088-foot mountain that is 12.5 miles from the runway, or does the plane need to increase its angle of ascent? Okay, so here is what this situation looks like. Here's the runway. The plane takes off at an angle of 12 degrees with the ground. So it's climbing, gaining elevation, and it needs to clear this mountain over here. The question is, and it takes off 12.5 miles away from the height of that mountain. So does it get high enough to clear the mountain? So how high does it get? We're trying to figure out this value right here. So we've been working with right triangles, so you might say, can't we just do Pythagorean theorem? I mean, we have that down, right? So sometimes you have situations where in a right triangle, you don't know two sides to use Pythagorean theorem to find the third side. Pythagorean theorem is a great tool, but it requires knowing two sides of a right triangle. In this example, we know one side of a right triangle. We're trying to find another side. We don't know this hypotenuse. If we did that, yes, Pythagorean theorem, of course we could use it. So trig ratios and trig functions help us solve for missing parts of right triangles when you're given limited information. Okay, so what we're going to do is we are going to identify, we're working with a 12-degree angle. We want to find the opposite side, that's x, and we are given the adjacent side. So if you think through our three trig functions, only one of those uses the opposite side and the adjacent side. It's not sine, it's not cosine. Those both require the hypotenuse, but our tangent function uses the opposite and adjacent. So what we're going to do is we're going to set up what we call a trig equation. Tangent of our angle 12 degrees is equal to the opposite side over the adjacent side. So it's equal to x over 12.5. We have an equation we can solve for x. What I like to do is make this a fraction on the left side. So you have a fraction equal to a fraction. We just solved a ton of proportions in the last chapter, so let's just solve the proportion. We'll cross multiply. X times 1 is x equals tangent of 12 degrees times 12.5. It's easiest to write that as the 12.5 first times tangent of 12. So you might say, well, I don't know what the tangent of 12 is, but your calculator does. You have a tangent button that you can type in tangent of 12 degrees and basically get the decimal value for what that ratio would have given you, the opposite over the adjacent. So what we do is we type 12.5 times tangent, type in a 12, you hit enter, and we find that x is equal to about 2.66. Now because we used a unit of 12.5 miles in our equation, this is in miles, our answer. So the airplane is going to reach a height of 2.66 miles after it has covered a horizontal distance of 12.5 miles. Is this high enough to clear the mountain? So let's look back at the problem. How high is this mountain? Oh, okay, so our mountain height is in feet. So we're going to convert to feet. Let's recall that 1 mile is equal to 5,280 feet. Since we know our mileage, we can just take our 2.66 miles. There are 5,280 feet in each of those miles, so we'll just multiply it by 5,280, and we get 14,044.1 feet. So the plane will reach an elevation of 14,044 feet. So to answer the question, yeah, the plane will clear the top of the mountain. Okay, so follow-up question where we get to practice these skills again. If a plane climbs at 5 degrees and flies 20 miles through the air as it climbs, what is the altitude of the plane to the nearest foot? So here's the situation. The plane is climbing into the air. They want to know what the altitude is. So we draw straight down. I'm going to go ahead and draw on the ground. And let's figure out what we know. It is a 5 degree. It says it climbs at 5 degrees. So that's going to be that angle here. And then it says 20 miles through the air as it climbs. So what that means is that this is where the plane is climbing through the air. So this is going to be 20. And we are in miles, right? 20 miles. What is the altitude of the plane? Altitude is a measurement, a height measurement, straight up and down. So there's our altitude. Okay, well, we need to know this. I can't use Pythagorean theorem, so I'm going to use a trig equation. All you need is one of your angles that's not the 90 degrees in one side of a triangle, and you can find missing parts of your triangle. So because we have a 5 degree angle, that makes x the opposite side and the 20 the hypotenuse. I kind of went in reference to where our angle was. So which trig function uses opposite and hypotenuse? That's going to be our sine function. So we're going to say sine of 5 degrees equals the opposite side x over the hypotenuse of 20. Let's make that a fraction so we can cross multiply. 1 times x is x. Sine of 5 times 20, let's write the 20 first. So 20 times sine of 5 degrees. Then we grab a calculator and type that in. 20 times sine of 5 degrees is 1.74, and we are in a unit of miles. So the plane reaches an altitude of 1.74 miles. But they want this rounded to the nearest foot. So let's convert to feet. We're going to take our 1.74 miles, multiply it by our feet per mile, 5,280, and we get 9,187.2, but rounded to the nearest foot will be 9,187 feet.